Okay, continuing with chapter 18, and this talk is on mechanical events of the heart. So, we are going to first introduce some terms. And the first term is systole, and this is a period of heart contraction. And then we also have diastole, and that's going to be the period of heart relaxation. And then the cardiac cycle is blood flow through the heart during one complete heartbeat. And this is going to be atrial systole and diastole, which is going to be followed by ventricular systole and diastole. The cycle represents a series of pressure and blood volume changes, and mechanical events follow electrical events seen on the ECG. And then there's 3 phases of the cardiac cycle, and we are going to go over them now. So first we have ventricular filling. This is mid to late diastole. So pressure's low, and then 80% of blood is just going to passively flow from the atria through the open AV valve into the ventricle. During this period of time, the semilunar valves are closed. Then we have atrial depolarization, which is going to trigger atrial systole. Okay, the atria are going to contract. When the atria contract, they're going to push the remaining 20% of the blood into the ventricle. And this is when we introduce another term, end-diastolic volume. And that's the volume of blood in each ventricle at the end of ventricular diastole. Then depolarization spreads to the ventricles, the QRS wave. And then the atria finish contracting and return to diastole when ventricles begin systole. Then we have the second part, atria relax. And then the ventricles begin to contract. As the ventricles begin to contract, the pressure is going to go up in the ventricles, which is going to cause those AV valves to close. Remember, those AV valves are there to make sure that blood goes in one direction, and that's from atria to ventricle and then out of the heart, not back up from atria to ventricle back to atria. And then we have the term isovolumetric contraction. And during isovolumetric contraction is a split-second period when the ventricles are completely closed, so both the AV valves and the semilunar valves are closed. The volume remains constant, and the ventricles continue to contract. Now, at some point, ventricular pressure is going to exceed the pressure in the large arteries, and at that point, the semilunar valves open, or they're forced open, and the pressure in the aorta reaches about 120 mmHg. And then we have the third and final part. And so following ventricular repolarization, T wave, the ventricles relax. And then we introduce another term, end-systolic volume. And this is going to be the volume of blood remaining in each ventricle after systole. And then ventricular pressure drops, causing backflow of blood from aorta and pulmonary trunk, and this is going to trigger the semilunar valves to close. Then the ventricles are completely closed chambers momentarily, and this is going to be referred to as isovolumetric relaxation. The closure of aortic valve raises aortic pressure as backflow rebounds off of closed cusp. So we're going to see an actual, basically what this means is the pressure, the blood's going to flow out of the ventricle into, let's say, the aorta, okay? And then the semilunar valves are going to close, and then it's going to rebound off of the closed valves. And this is called dicrotic notch. The atria continue to fill during ventricular systole when atrial pressure exceeds ventricular pressure, AV valves open, cycle begins again. The heart beats around 75 times per minute. The cardiac cycle lasts about 0.8 seconds. So of this 0.8 seconds, 0.1 seconds is atrial systole, 0.3 seconds ventricular systole, and then 0.4 seconds is a quiescent period, and this is total heart relaxation. So this is a lot of information right here. And I want to point all this out. Actually, let's make it bigger. Make it bigger and move it around. Okay. So we have here P wave, QRS, T wave. It's kind of spread out, which is good. Okay. And what we're doing is we're trying to look at this stuff together. And this down here, the purple line is atrium, left atrium. And the blue line is left ventricle, and the green is the aorta. Okay, so what happens here is P wave, atrial depolarization, and then the atria are going to contract, and that's what we see, a rise in the pressure in the atria. Okay, then we have ventricular depolarization here, and at ventricular depolarization, then the pressure in the ventricle is going to go way, way up, 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 up. And then we have ventricular repolarization, and the pressure in the ventricle is going to go down. Some other things I want to show you. This point right here, this is where the AV valves are going to close. So at this point, ventricular pressure actually exceeds atrial pressure, and so the AV valves will close. Here, this is where the ventricular pressure is going to exceed that in the aorta, and this is where the semilunar valves open. Then we go down to here, and this is where the semilunar valves close. This is also dicrotic notch. This period right here, this is the dicrotic notch. And then this, when the ventricular pressure goes back below the pressure in the atria, then the AV valves open back up. This is showing the volume of blood in the ventricle. So this, again, this is the period of time when the atria are basically blood's just passively moving into the ventricle. 80% of that blood passively moves. And so that's what we're seeing here. And then we see this little kind of point where we're going up a little bit faster. And this is because the atria contract and pump the remaining 20%. Then we have this period right here. This is isovolumetric contraction. The volume of the the ventricle remains the same. This is isovolumetric contraction. At this point, again, we go back up to here. Ventricle are depolarizing, which means that it's contracting. And when it contracts, the volume in the ventricle goes down again, down, down, down. And then we get down to here. And this is isovolumetric relaxation. This is just showing the same thing that I was just talking about, but it actually shows the AV valve and the semilunar valves opening and closing on here, as well as a dicrotic notch. And this also shows that the heart sounds actually are caused by the valves closing. So the first heart sound is caused by the AV valves closing. The second heart sound is caused by the semilunar valves closing. And that's what we have here. So heart sounds, two sounds, loved up, associated with the closing of the heart valves. The first one is the AV valves. The second is the closing of the semilunar valves. And the pause between loved ups indicates heart relaxation. The mitral valve closes slightly before the tricuspid, and the aorta closes slightly before the pulmonary valve, and the differences allow auscultation of each valve when the stethoscope is placed in 4 different regions. So this just means that when you place the stethoscope here, you can hear the aortic valve, here pulmonary valve, here mitral valve, and here tricuspid valve. I'm not going to ask you where you need to place your stethoscope to hear each one of these valves. I do want you to know that placing them in different places is going to allow you to hear different valves though. And then here are your questions. That's all I have for you.